Hi all, welcome to question number 39, the final question in the question paper and the final episode of our question paper based discussion session. Let's begin. This question is usually asked from electricity chapter and it's an OR question. Let's begin. Two resistors with resistances 50 and 100 respectively are to be connected to a battery of 6 volt so as to obtain maximum current and minimum current flowing. With the help of a circuit diagram, show how to connect the resistances in each of the above cases. So first of all, let's do that one. Before starting that, we should be knowing something that in parallel connection, resistance is minimum and in series connection, resistance is maximum. Now let's come to the question. Here they are saying only about current, minimum current and maximum current. From Ohm's law, we have the equation V is equal to I into R. So from this, they already told us that the potential difference is a constant. So this is remaining constant. So if we have to obtain a maximum current, then the resistance should be minimum. So if the current should be maximum, then the resistance should be minimum. Resistance is minimum in the case of parallel connection. So here it is parallel connection. Coming to minimum current, if the current is supposed to be minimum, then the resistance should be maximum. Resistance is maximum in series connection. So here it is series connection. Now let's come to A part of the question. In A part, they are asking us to draw both the diagrams. So first one is parallel connection. It is 50 ohm and 100 ohm connected parallelly to a 6 volt cell. So we have 50 ohm here and 100 ohm here. It is connected parallelly to a cell of 6 volt. So here we have the 6 volt cell, here we have the 50 ohm and here we have the 100 ohm. Now B part of the question, there it is series connection. So in series connection, first resistance here, that is 50 ohm, and the second resistance here, that is 100 ohm, it is connected to a cell of 6 volt. So this is the first part of the question. Now in the second part, calculate the strength of the total current in the circuit in two cases. In both the cases, now we'll have to find out the total current. We know the equation V is equal to IR, that is Ohm's law. So using Ohm's law, we'll be able to calculate it. But for that, we should be knowing the effective resistance. So in this case, what will be the effective resistance in parallel? So 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by Rp is equal to 1 by R1, that is 1 by 50 plus 1 by 100. So 50 into 2 if we do here, then 1 by Rp is equal to 2 plus 1, that is 3 by 100. Or therefore we can write Rp is equal to 100 by 3 ohm. This is the effective resistance here, the parallel resistance here. So now we'll try to find out the current using this equation. So from this equation, V is already known to us, that is 6 volt. So 6 is equal to I into the effective resistance is 100 by 3. So if I keep I here, then I is equal to 6 into 3 divided by 100. So here 6 into 3, 3 6 are 18. 18 divided by 100. That will be equal to, the decimal will jump towards left side 2 times. We'll get 0.18 ampere. So the first answer, the first current, the total current in the first circuit is 0.18 ampere. Now let's go to the second one. Here effective resistance R series is equal to 50 plus 100, since it is series connection. So it is 150 ohm. Now let's find out the current in the same way. Using Ohm's law, V is equal to I into R. V is already known, that is 6 is equal to I, we have to find out, into the resistance. Resistance is 150. So I is equal I is equal to 2 divided by 50, that is equal to 1 by 25. If we want to write in decimal form, we can write it like 0.04 ampere. So this is the current here. So in parallel connection, the total current will be 0.18 ampere, and in series connection, the total current will be 0.04 ampere. So as they have asked in the question, we can see this is minimum current when it is connected in series, and this is the maximum current when it is connected in parallel. We'll go to the next question. Here, a 5-meter tall object is placed perpendicular. So, height of the object is given here. Height of the object is 5 centimeter. 5 centimeter is placed perpendicular to the principal axis of a convex lens. So, this is lens and it is convex, of focal length 20 centimeter. So, focal length is 20 centimeter. Since it is convex, the focal length will be positive. The distance of the object from the lens is 30 centimeter. So, object distance is given as 30 centimeter. We know always object distance should be taken as negative. Find the position, nature and size of the image formed. So first of all, we should find out the image distance, then the size of the image, that is height of the image, and the nature of the image formed. Later we have to draw a ray diagram as well. So first of all, let's find out this one. So here this is lens. So using lens formula, 1 by V minus 1 by U is equal to 1 by F. Let's substitute all the values. 1 by V is not there, 1 by V as it is, minus 1 by U is 1 by minus 30 is equal to 1 by F is 20. Let me keep 1 by V here, is equal to 1 by 20. Here minus into minus will become plus. When the plus goes to this side, it will become minus. Minus 1 by 30. So now 1 by V is equal to 30 minus 20. I'm cross multiplying, divided by 2 3s are 6, 600. So 1 by V is equal to 30 minus 20 is 10. 10 divided by 600, 0 0 got cancelled. So V is equal to 60 centimeter. So image distance is equal to 60 centimeter. Now we have to find out. So V is already found out. Now we have to find out the height of the image. Height of the object is already here. So to find out that, we have a relation connecting all the three. That is, magnification is equal to height of the image divided by height of the object. That is equal to, this is lens. So lens formula, in lens formula minus is coming. So in magnification, the minus will not come. So it is V by U. Or else in mirror formula, it is 1 by V plus 1 by U. So magnification will be minus V by U. Now let's substitute the given values. M is not needed. Let's substitute the other given values. Height of the image, we are going to find out that, divided by height of the object is 5, is equal to V by U. V is 60 and U is minus 30. 30 into 2. So height of the image is equal to minus 2 into 5, that is minus 10 centimeter. So height of the image is minus 10 centimeter. Here if you see, it's a convex lens. The object is kept towards the left side and the image is received on the right side, which means on the screen. So it's forming a real image. Always real image will be inverted as well. So we are getting a real and inverted image. If you look at the size, then image, height of the image is minus 10. Height of the object is 5. So image height is much higher, 2 times higher than the height of the object. So it's enlarged as well. So these are the properties or the nature of the image formed. It's real, inverted and enlarged. Now next part is draw a ray diagram showing object distance, image distance and focal length in the above case. So we have to draw it in the above case. So let's analyze the case once again. This was a convex lens. So if we draw a convex lens is something like this, where we have f1 here, 2f1 here, f2 here and 2f2 here. Here the centimeter, the focal length from here to here, the distance is 20 centimeter. Now the object is kept at minus 30 centimeter. We know till here it will be 20 plus 20, it will be 40. It's not reaching 40, it's reaching 30. So it's in between. So the object is kept here in between. We have to make a ray diagram of this one. So if the object is between f1 and 2f1, it is similar to the concave mirrors case where it is between C and F. We will get it beyond C. Here we will get it beyond 2f2. The image will come over here. Let's take the first ray, that is parallel. The parallel ray will go through the focus. It will go like this through the focus. Second ray, let's take it through the optic center. When it is taken through the optic center, it will go like this. And both will meet somewhere here. We will get the image here. So this will be the ray diagram. Let's move forward to the next question. A concave lens of focal length 60 centimeter. So it's concave and it is lens. Its focal length is 60 centimeter. So f is equal to 60 centimeter. It's concave, so it should be negative. Is used to form an image of an object of length 9 centimeter. So height of the object is given to us, that is 9 centimeter. Kept at a distance of 30 centimeter. And this object is kept at a distance of 30 centimeter. Always we used to say object distance is negative. Use lens formula to determine the nature, position and the length of the image formed. We have to find out the image distance and height of the image. Also draw label ray diagram. Ray diagram is also needed. Okay. So first of all, let's use the lens formula and find out the image distance. Lens formula is 1 by V minus 1 by U is equal to 1 by F. Let's substitute all the values here. 1 by V as it is, minus 1 by U is 1 by minus 30 is equal to 1 by F is minus 60. Now 1 by V is equal to 1 by minus 60. Here minus into minus will become plus. When this plus goes here, it will become minus 1 by 30. Or I can write it like 1 by V is equal to minus of 1 by 60 plus 1 by 30. If I multiply here with 2, it becomes 60. So 1 by V is equal to minus of 1 plus 2, that is 3 by 60. If I take the reciprocal, V is equal to minus of 60 by 3. 3 goes 2 times in 60. So it becomes minus 20 centimeter. So our V is equal to minus 20 centimeter. Now we have to find out the height of the image. As we did earlier, we have the relation magnification is equal to, here it is lens formula. So already minus is there. So it is V by U is equal to height of the image divided by height of the object. We'll substitute the values here. V is minus 20 divided by U is minus 30. that is equal to height of the image. Height of the image we are going to find divided by height of the object is 9. Here 0, 0, minus, minus got cancelled. So now height of the image is equal to 2 by 3 into 9. 3 3s are 9. 2 3s are 6. So we got height of the image is equal to 6 centimeter. Now we have to draw the ray diagram for this. To draw the ray diagram, let's analyze the question once again. It's a concave lens. So let me draw the concave lens here. We have the concave lens, the principal axis.
Now the focal length is 60. So when we mark here, this is 60. And double of that is 120. And now our object distance is 30. So our object will come somewhere here. It's not even reaching our focal length. So first ray parallel will go like this. When we extend it, we'll feel like it's coming from the focus, and second ray will make it pass through the optic center, and we'll get the image here. So as we can see, the image is very small. So it is virtual. We cannot obtain it on the screen, and it is erect. And when we observe, it's very much less than the size of the object, so it is diminished. Here, a letter A consists of a uniform wire of resistance 1 ohm per centimeter. The side of the letter are each 20 centimeter long, and the cross piece in the middle is 10 centimeter long. With apex, angle is 60 degree. Find the resistance of the letter between each of the legs. So now we'll just redraw this figure. We'll start from B. So when we start from B, first we have a resistor. That resistor is connected to two other resistors in parallel, and the top one is again connected to the next resistor, and from there both are joined together and connected to the last one, to C. So now we have a new question. It is very simple now. So everywhere it is 10 ohm resistor. So now the center portion. In center portion, the first two are in series, and the bottom one is connected in parallel to that. So when it is series, 10 plus 10, we have 20 there. And now again the figure will change. So we have a 10 ohm, then 20 ohm and 10 ohm in parallel, and one more 10 ohm. So let's find out the effective resistance at the center part. So 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by Rp is equal to 1 by 20 plus 1 by 10. So into 2, we'll get 1 by Rp is equal to 3 by 20. Rp is equal to 20 by 3 ohm. That is equal to 6.6 ohm. Now we have 10 ohm, 6.6 ohm, and another 10 ohm in series. So let's add all those three. So R effective is equal to 10 plus 6.6 plus 10. That is 10 plus 10, 20 plus 6.6. We'll get 26.6 ohm. That's the answer. Next question is to define power and state its SI unit. So when we hear power, we will be confused between the power in the lens chapter and the power here in electricity chapter. So since the other question is also connected to electricity, anyway they are asking about the power in electricity chapter. So we have to write that one. So power is the rate at which energy is consumed, or rate at which electric energy is dissipated in an electric circuit. The SI unit of power is watt, which is represented using capital letter W. Now going to the B part of the question, a torch bulb is rated 5 volt and 500 milliampere. So voltage in milliampere is given. So the potential difference V is equal to 5 volt. And the current is given in milliampere, that is I is equal to 500 milliampere. we have to convert that to ampere, that is equal to 500 into 10 raised to minus 3 ampere. Now we will substitute the values. Power P is equal to what? We have to find out P. Then again we have to find out the resistance also. And the energy. How much of energy is dissipated in 2.5 hours. Now we'll substitute the values in the equation. Equation is P is equal to V into I. That is equal to 5 into 500 into 10 raised to minus 3. So that we will get the answer as 5 into 5 is 25, 0, 0 into 10 raised to minus 3. We are dividing with 1000 here. So which means the 0 will jump towards the left side 3 times. We will get 2.5 watt. SI unit of power is watt. Now the next part is to find out the resistance. So in order to find out the resistance, we know the equation P is equal to V square by R. Another equation to find out power. Now we will substitute the values here. We already got the power. Power is equal to 2.5 watt. I'll write 2.5 here is equal to potential difference V is 5. So it is 5 square or 5 into 5. 5 into 5 divided by the resistance. We are going to find out the resistance. We'll interchange the values. R is equal to 5 into 5 divided by 2.5. 2.5 will go 2 times in 5. So it is 5 into 2. R is equal to 10 ohm. 10 ohm is the answer. The next part of the question is to find out energy. We know energy is equal to power into time. Power is already there in our hand, that is 2.5. So 2.5 into the time given as 2.5 hour again. So 2.5 into 2.5. Here we need not convert it to SI unit because energy is usually taken in the SI unit watt hour. So it is power into time. 2.5 into 2.5 will get 25 into 25 is 625. So we will get 6.25. 6.25. The SI unit is watt hour. The unit that will take is watt hour. So we got the energy consumed, that is 6.25 watt hour.
Let's see the next question. The variation of image distance with object distance for a convex lens is given in the following observation table. Analyze it and answer the questions that follow. Convex lens, it will form all types of images: virtual, erect, real, inverted. So at different positions, different kind of image will be formed. So let's analyze the table. When we get a table like this, the first point that we should notice, we should find out where will be U and V same. We know when object is kept, in the case of a concave mirror, when the object is kept at center of curvature, we'll get the same image also at the center of curvature with the same size. In the same way, when we keep an object at 2f1, in the case of a convex lens, we'll get the image at 2f2 on the opposite side, which is similar to the center of curvature. So here let's find out such value. Here it is 150 30 minus 75 plus 37.5 minus 50 plus 50. So you see this value minus 50 and plus 50, both are similar values, which means this is 2f1 or 2f value. This is the 2f value. So the focal length will be 2f, means it is similar to the radius of curvature. So our focal length will be half of this. That idea should be there with us. Again, one more thing is, we know when the object is kept at infinity, image will be formed at focus. And if the object is kept at focus, image will be formed at infinity. So it will be, the relation will be like that. Here we can see 150. Along with 150, we have the number 30. Just look here. Along with 150, we have 30. Same way, with 30, we have 150. With minus 75, we have 37.5. With 37.5, we have 75. 50, we have 50. So this will be the special case where the object is kept very much near to the lens. So that time we'll get a virtual image on the same side. Okay, these many things should come to our mind when we get a table like this. Now let's go to the first question. First question is, without calculation, find the focal length of the convex lens. Justify your answer. We have already done that here. Let's do that one once again. We told that at 2f, the object distance and image distance will be equal. So 2f, or the radius of curvature here, is equal to 50. It's a convex lens, so it's positive. It's plus 50. So the focal length will be 50 by 2. That is r by 2. This is actually r by 2. That is 50 by 2. So f is equal to plus 25 cm. Without calculation, we already did this in the beginning, but still we are just showing it through the calculation. The reason is the object distance and image distance will be equal when the object is kept at the center of curvature, or when the object is kept at 2f. So the focal length will be half of 2f. That's how we are getting this answer. Now, with which observation is not correct? Here, when the object is always kept towards the left side. Object is always kept towards the left side. So here we should have a negative value everywhere. Let's see here whether we are having a negative value or not. We have negative value everywhere. And the image is always formed on the right side. A real image is always formed on the right side. So starting from here till here, it's a real image. But last case is a special case where image is formed on the same side. So there, instead of positive, negative is supposed to come. So this last reading is a wrong reading. It's not correct. Why? The question why is there? It is because when the object is kept at minus 15, it's a value less than its focal length. So there, a virtual and erect image will be formed on the same side of the lens. Same side means the left side. If it is left side, it should be negative. But here it's given positive. That's why it is wrong. Now, last one is, draw a ray diagram to find the position of the image formed for this position of the object. The position is last position, this position. Let's do that one. In a previous question, we already did that, but still we'll do it once again. So it's a convex lens. We'll draw the convex lens. F1 to F1, F2 to F2, F1 to F1, F2 and to F2. Object is kept at minus 15. The focal length is 25, so it's kept before that. It's kept somewhere here. First ray parallel. We'll go through the focus. Second ray will go through the optic center. When it goes through the optic center, anyway, they are not meeting anywhere. But when we extend it here, when we extend both the rays, they are meeting somewhere here. So we'll get the image somewhere here. So a virtual, erect and enlarged image is formed here. Next one is, find the approximate value of magnification when u is equal to minus 30 centimeter. Let's see where it is minus 30. Minus 30 is here. So we know the magnification value. Magnification equation is m is equal to its lens. So it is v by u. That is equal to v. Here v is plus 150. So let me write it there. 150 divided by object distance is minus 30. So divided by minus 30. So magnification is equal to 0, 0 got cancelled. 3 5s are 15. So we got minus 5. Magnification is minus 5. Minus 5 means minus stands for it's a real and inverted image, and a value greater than 1, it means it's enlarged. First question is, state laws of reflection of light. We know The laws of reflection of light. First law states that angle of incidence is always equal to angle of reflection. Second law states that the incident ray, the reflected ray, the normal at the point of incidence all lie in the same plane. These are the laws of reflection. Now, second question is an object of height 5 centimeter. An object of height. So height of the object is given as 5 centimeter is placed at 15 centimeter in front of a concave mirror. So object distance is 15 centimeter. It is kept towards the left side always. It's a concave mirror of focal length 10 centimeter. Focal length is 10 centimeter. It is concave, so it should be negative. At what distance from the mirror should a screen be placed so that the focused image is obtained? Indirectly, they are asking us the image distance. Find the height of the image. We should find out the height of the image as well. So here it is concave mirror. So we have to use mirror formula, that is 1 by V plus 1 by U is equal to 1 by F. 1 by V is unknown. We'll write it as it is, plus 1 by U. 1 by U is 1 by minus 15 is equal to 1 by minus 10. I'll keep 1 by V here is equal to 1 by minus 10. Here minus into plus, it is minus. Minus when it comes here, it will become plus 1 by 15. I'll just rearrange and write it. 1 by V is equal to 1 by 15 minus 1 by 10. We'll just cross multiply. 1 by V is equal to 1 into 10 is 10 minus 15 divided by 150. So it will be 1 by V is equal to 10 minus 15 is minus 5 by 150. I'll take the reciprocal. V is equal to minus of 150 divided by 5. 5 3s are 15. So V is equal to minus 30 centimeter. So we got the image distance. Now we have to find out the height of the image. So height of the image can be found out using the magnification equation. M is equal to height of the image by height of the object, or it also can be written as, here this is mirror, so in mirror formula plus is coming, so in magnification minus will come, minus V by U. Let me substitute the values here. Height of the image, I'll write it as it is. Height of the object is 5 is equal to minus of V. V is minus 30 divided by U. U value is minus 15. Here minus into minus became plus. Now height of the image is equal to, here 15. 15 into 2 is 30. So now height of the image is 5 into 2. 5 2s are 10. 1 minus is remaining. Let's discuss question number 39 from the CBSE model question paper as well. So as per this question, a diagram is given. It's from electricity chapter, and the arrangement of resistors shown in the above figure is connected to a battery. The power dissipation in the 100 ohm resistor is 81 watt. We have to calculate the current in the circuit, then the reading in voltmeter V2 and the reading in voltmeter V1. Let's see how to do this. So here they have specifically told us about the power dissipation in the 100 ohm resistor. The power across this 100 ohm resistor is given to us already, that is 81 watt. Why have they given it like that? Because we know here, if we consider the single resistor and these two resistors as a team which is connected parallelly, this parallel connection and this resistor both are connected in series. We know in series the current will be same, voltage will be different. But in parallel connection, if we consider only this team, then the potential difference across these two should be a same value, which will be across this voltmeter. Let's go to the first question first. The current in the circuit should be found out. So we know in series connection current is same. So in this entire circuit, if we calculate the current across this 100 ohm, that same current, let me call it as I100. If I find out this current, that current will be the current around all around this circuit. So let us try to find out that one. So for that, first of all, we have the resistance. Resistance is equal to 100 ohm, and the power is given as 81 watt. We have to calculate the current. We know the equation connecting R, P and I, that is P is equal to I square R. Let me substitute the values. P is 81 is equal to I square as it is, and the resistance, that is into 100. If I keep this I square here, that is equal to 81 divided by 100. If I take the square root on both the sides, then square root and square will get cancelled. Here square root of 81 is 9 divided by 10, that is I. So I is equal to, the value of I is equal to 0.9 ampere. So we got the current. This is the current across this resistor, 0.9, and this is the current across this circuit as well. Let's go to the second part of the question. The reading in voltmeter V2. We have to find out the reading in voltmeter V2. V2 is this one. The potential difference here, here and here will be equal. If we have to find out the potential difference here, first of all we should find out the equivalent resistance here. The RP, R parallel should be found out. So let's do that one first. 1 by RP is equal to 1 by R1 plus 1 by R2. Here both are same resistors, that is 25, so the effective resistance will be half of it, that is 12.5, but still we will show the steps. 1 by Rp is equal to 1 by 25 plus 1 by 25, that is equal to 2 by 25. Rp is equal to 25 divided by 2. If needed, we can stop it here since we're continuing, or else we can write like 12.5 ohm. Okay, now let's come to the second part of it. We are going to find out the reading of this voltmeter. We know again from the equation, we know from Ohm's law, V is equal to I into R. So here the potential difference here will be equal to I. We already got the I value here. This I value is common for this part and this together part. We already told that one. So I can write it here like 0.9, or I can write 9 by 10, the fractional form, into the resistance. Resistance was 25 by 2. Let me write that one, 25 divided by 2. So now if I cancel, this is 2, 5 2s are 10, here 5 5s are 25. Now I have V is equal to 9 5s are 45 divided by 4. 4 goes one time in 4, 4 goes one time in 5. So we'll get 11.2 volt. That is the potential difference across V2. Now next one is the reading in the voltmeter V1. Now we have to find out V1. V1 is actually the total potential difference present across this cell, which means the total potential difference that is present in this circuit. So now we got the potential difference across these two sets. Among these two, we got 12.2. So if we get the potential difference across this 100 ohm, then if we add both, then we'll get the total potential difference. That will be easy method. So let's try to find out the potential difference across the 100 ohm. So now V across 100 is equal to what? Now here we have the resistance and we have the current we have the power as well. So connecting all those, we have the equation P is equal to V into I. Here P is already given in the question, that is 81. So let me write 81 here. That is equal to potential difference. We are going to find out that one, and into current. The current here, we already found out that one. The current here is 9 by 10. We already got it. It's 9 by 10 or 0.9. So let me write that 9 by 10 there into 9 by 10. If I keep that V there, so V is equal to 81 into 10 divided by 9. 9 9s are 81. So we'll get V is equal to 90 volt. So here potential difference across this one is 90 volt, and the potential difference across this is 11.2. It's 11.2 volt. So now the total V total will be equal to this 90 plus 11.2. That is equal to 90 plus 10, 100. So 101.2 volt. This is the answer. So we got the current in the circuit initially, that is 0.9 ampere. Then the potential difference across V2, that was also got 11.2. Now the total potential difference across the voltmeter V1, that is 90 plus 11.2, that is 101.2 volt. We'll go to the OR question. Again we have a similar question here. An electric heater consists of three similar heating elements A, B, C connected as shown in the figure above. Each heating element is rated as 1.2 kilowatt. So the power is given here, power is in kilowatt. So when we calculate, we should convert that to watt. Then 240 volt. The potential difference is also given and has a constant resistance. So they have constant resistance. S1, S2 and S3 are respective switches. There are switches S1, S2 and S3. Now, first question is calculate the resistance of one heating element. We have to calculate the resistance. They already informed that all these three resistors are similar. So if we calculate the resistance of one resistor, then automatically we are getting the resistance of all other resistors. So let's write the given values. Each heating element is rated as 1.2 kilowatt. So power is given 1.2 kilowatt, which is equal to 1200 watt. We are multiplying with 1000. Now the potential difference is also given. The potential difference is equal to 240 volt. 240 volt. We have to calculate the resistance. Resistance should be calculated. We know the equation connecting power, resistance and potential difference. P is equal to V square by R. Let me substitute values here. P is 1200 is equal to V square is 240 into 240 divided by resistance we are going to find out. I'll just interchange. R is equal to 240 into 240 divided by 1200. 0 cancelled. 12 into 2 is 24. So resistance R is equal to 2 into 24, that is 48 ohm. Resistance is 48 ohm. So each resistor is 48 ohm. We got that information from this. Now second part of the question, calculate the current in each resistor when only S1 and S3 are closed. So they are closing this S1 and S3. When they close it, we actually have a series connection here which is connected parallelly to C. A and B are connected in series which is connected parallelly to C. So calculate the current in each resistor when only S1 and S3 are closed. So we have to calculate the current across A, current across B, current across C. We have to calculate IA, IB and IC. From Ohm's law, we know V is equal to I into R, or I is equal to V by R. Let me take that one. But here we have an issue, because here this connection is in series. In series connection, current is same. But these two are connected in parallel with C. So here the current will be different. IC will be different, but IA and IB will be same. So first of all, let's find out the current here using any one of the resistors. Let me find out across IA. IA and IB are equal. So now let me find out one. I is equal to V by R. Substituting the values there. V, the potential difference there is 240. We are able to take 240 because these two are connected in parallel with this 240 power supply. So they both are in parallel. So altogether here we'll have a parallel connection, divided by the effective resistance here, that is 48 plus 48. Now we can cut it and make it short. Here it is actually 240 divided by 96. When we make it short, we'll get 5 by 2. We'll get 5 by 2 is equal to 2.5 ampere. It is equal to 2.5 ampere. So here the current across A and the current across B are same, and they are 2.5 ampere. Now we have to calculate the current across C, the resistor C. Let's see how to calculate that one. We'll use the same method here. The current across C, that is IC, is equal to again V by R. Here the potential difference is same as we saw, that is 240 divided by the resistance. Each resistor is 48. We got it in the beginning. So 240 divided by 48. When we make it short, we'll get 30 by 6, which is equal to 5 ampere. So here it is 2.5 ampere and here it is 5 ampere. We'll go to the next part of the question. Calculate the power dissipated across A. The power dissipated across A when S1, S2, S3 all are closed. So they are closing S1, S2 and S3. S3 is already closed. They are closing S2 also. Here, when they close S2, actually the current will flow through this part. The current will be flowing like this. It won't flow through this resistor because current always take easy path. So now this resistor is actually cancelled. It got cancelled here. This resistor is not there at all. Now we only have A and C, which are connected in parallel. Now we have to calculate the power dissipated across A. So how much power will be there across A? So we know the equation, power is equal to, here we know the potential difference, so we can write like V square divided by R. That is equal to V square, the potential difference across A. That is same as the total potential difference, that is 240 into 240 because it's square. 240 into 240 divided by the resistance is 48. 24 goes 2 times in 48 and 2 goes 12 times in 24. So we will get it like 1200. It is power. So power is in watt. So we got 1200 watt as the answer. So far we have discussed all the questions in physics part starting from question number 30 till question number 39. Now it's your turn. Prepare well, study well, write the exam well. Wishing you all the very best for your exam. Stay calm, trust your preparation, and give it your best shot. Good luck. Thank you.